Hi everyone, it's Coach Fred, and today I'm going to be talking about how you solve an equation using the inverse property of an exponential using a logarithm. So we've kind of mentioned this a lot. Like when we try to solve the equation x squared equals 25, the reason we're allowed to take the square root of both sides to get x equals plus or minus 5 is because we're using the inverse to a quadratic, which is a square root, right? We're using the inverse operation. So we now know that the inverse of an exponential is a log, right? Now, our first goal, if we have an exponential equation, number one should be that you should always see if you can make the bases the same, right? But 5 and 7 don't have a common base. Now, we also learned before I'm teaching you to do this, that you could actually put this in your calculator. You could put in y equals 5 to the x and y equals 7 and find the point of intersection of the two functions that you put in your calculator. That's another way to solve. Again, these are going to be estimates, okay? Because when you use the logs, you are going to be getting, irrational numbers. So, or non-terminating, non-repeating decimals. So, okay, so how do we undo an exponential function? Well, we're going to use logs. Okay, so watch. And we're going to have to use algebra and our properties as well. All right, so if I want to try, I can't make the bases the same. I'm looking at 2 to the x equals 15. I'm going to take the log of both sides. And then I'm going to use the properties of logs, which tells me that exponent can come to the front. So now I have x times log 2 equals log 15. Next step, just divide by log 2. Remember, it's a number. It's not a word. All right, so x equals log 15 divided by log 2. Now, that is what I'm going to call calculator ready. So if I give you a non-calculator test, that would actually be how you'd leave your answer. But if I want an approximation, I'm going to go to my calculator, which I have up here, and I'm going to clear out everything I have here, and I'm just going to put in log 15 divided by log 2. And we get approximately 3.97. 3.917. Okay? All right, so, not too hard when they're just these basic logs. So you could do, again, log 6 to the x equals log 9. You're taking the log of both sides. You bring the power, use the power rule, and bring the x to the front. I keep switching between my cursive and non-cursive L's. Sorry about that. Divide both sides by log 6. Get a calculator ready answer, log 9 over log 6, and then grab that calculator. Now I do want to take 1 second here and just make sure you understand that log 9 over log 6 is not the same as that division property we did earlier. Okay, so those do not mean the same thing. Okay, this is, if you think about it, this is 1 and 1/2, right? So that would be log of 1 and 1/2. This is log 9 divided by log 6. So just make sure you don't mess that up. All right, so that's the basics. But what if they get a little bit more challenging? And they can. Well, the rules are still going to be the same. If they're unlike bases, right, you want to take the log of both sides. Okay, take the log of both sides. And that's going to be the route we take. But now let's look at them when they're a little bit harder. So you can see I've got more developed questions here. So we're going to solve for x, and we're still going to do the same thing. We're going to take the log of both sides. Now, again, use that power, bring it down. So x minus 1 times log 2 equals log 7. All right, I guess there are probably really 2 ways you could do this. The way I like to do it is I actually like to distribute the log. Okay, so that would give me x log 2 minus log 2 equals log 7. Okay, all right, and then I'm going to add log 2 to both sides. And so that would give me x log 2 equals log 7 plus log 2 over log 2. And there I have a really nice calculator answer. Some students actually divide by log 2 here and then add 1, but then it's just not in simplest form, so you have to simplify it a little bit more to get it calculator ready. So I find this just to be an easier method. So my final answer would be x equals log 7 minus log 2 over log 2. Okay? All right, let's look at this next one where I've got x's on both sides. Okay, this should be x minus 2. So let's leave it like, make it x minus 2. Can't make the bases the same, so I'm going to take the log of both sides. Okay, so now I actually have to bring the power down on both sides, and this is where it gets trickier. So now we have x log 4 equals x minus 2 times log 15. Now remember, we've got to get x alone. So it's going to be really important that you think about that here. So you do want to distribute your log. So this is really the best way to do this. So you're going to get x log 4 equals x log 15 minus 2 log 15. So like right now, if you're looking at this, you can see this 2 log x, this is a number, right? That's going to evaluate to a number. So, you know, the x's are in this expression and this expression, so we want to bring them together. So I'm going to subtract x log 15 to both sides. That's going to give me x log 4 minus x log 15 equals negative 2 log 15. Now, I'm hoping you notice that x is in both expressions, here and here, so you can factor out the x. Now you're noticing I'm not skipping steps here. This is not the place you want to skip steps, okay? You really, really don't. All right, and then when you factored that out, you can now divide by log 4 minus log 15 on both sides. And you have a calculator-ready answer. Negative 2 log 15 all over log 4 minus log 15. Okay, so that's going to take some practice. So what I'm going to suggest you do now is that you try number 2, the next 2 examples, press pause, and come back and hear the answer. Okay, so a calculator-ready answer I got was log 17 plus 3 log 10 divided by 2 log x. So you can kind of see what I did here. I first simplified. I brought the 2x minus 3 to the front, and then I distributed the log 10. Then, when I did that, I got 2x log 10 right here, minus 3 log 10. I added 3 log 10 to both sides. Now, when I got here, I had 2x log 10 equaled log 17 plus 3 log 10. You might notice what I divided by was 2 times log 10 because that's what I was trying to get to the other side, and it's all multiplication, so I could do that in one step. And so I got a calculator-ready answer of log 17 plus 3 log 10 all over 2 log x. Okay? All right, so hopefully that was helpful. You're going to try the next one. Again, press pause and come on back. All right, so if you're back, you can see that the final answer would have been log 2 plus 5 log 12 divided by 3 log 12 minus 2 log 2, and that would equal x. And that would be your calculator-ready answer. So take a second and look at what I did. I first took the log of both sides, brought my powers to the front. I distributed the log 2 and the log 12. I recognized that I had 2x on this side and a 3x on this side, so I brought the smaller over. I brought the 2x over. And then I brought the 5 log 12 to the left side, giving me log 2 plus 5 log 12. I then noticed that the 3x and the 2x were, I could take out the x, so I factored out the x, leaving me with 3 log 12 minus 2 log 2, and then I divided it out on both sides. So again, a calculator-ready answer. And so I want us to get these calculator-ready because putting in the calculator is the easy part, and I don't want you estimating or approximating until the absolute end because you get farther and farther away from the true answer. So for now, we're going to be doing them in calculator-ready form. All right, so there's extra practice on the website if you need it. Hopefully that was a helpful video. Have a great day.